Hey everyone, welcome. I'm super excited to have you here for this explainer because today we are diving into an absolutely brilliant solution for honestly one of 3D printing's most persistent and frustrating challenges. We're talking about taking total control of your manufacturing process right from your desktop and completely shifting how we think about creating physical objects. What if your parts just fit every single time? I mean, really think about that. We've all been there, right? You spend hours dialing in a machine, running endless calibration cubes, tweaking your flow rate, literally holding your breath while a print finishes, only to find that your perfectly modeled peg still won't fit into its hole. It's maddening. But today, we're going to learn how to just completely bypass that headache entirely. Okay, so here's our roadmap for today. First, we'll look at the perfect fit problem. Second, design over slicer settings. Third, the essential design toolkit. And finally, the digital warehouse future. Let's jump right in. All right, section 1, the perfect fit problem. Why tweaking fails. So, if you're a 3D printing enthusiast, you already know this endless loop of trial and error. You print, you test, it fails, you tweak the settings, and then you print again. It's exhausting. But here's the thing, just blaming the slicer software, that's a mistake. There are unavoidable variables that are always going to mess up your perfect physical dimensions. Plastics naturally shrink as they cool. That's just basic chemistry. On top of that, different color variations of the exact same filament can actually print slightly differently. Add in the microscopic, day-to-day quirks of an individual machine, and, well, it becomes pretty clear. You simply cannot just slice your way out of these physical realities. Moving on to section 2, design over slicer settings, a paradigm shift. Now, what's really interesting about this is the huge contrast. This paradigm shift is heavily championed by the massive printing operations over at Slant 3D. Their core philosophy? It's that design is the ultimate equalizer. Think about it. Relying on slicer settings is essentially just high-level guesswork. Sure, it might work perfectly for that specific roll of material, on that specific Tuesday, on that specific printer. But when you actually design for the manufacturing process itself, your part becomes universally robust. It becomes reliable and completely repeatable, anywhere, anytime, on literally any machine. And the best part is that this philosophy applies to a massive variety of connections. Whether you're modeling super tight press fits, satisfying snap fits, functional lids, or even complex interlocking parts, designing for the process ensures these connections work straight off the print bed. No more hours of tedious post-processing or recalibration. That brings us to section 3, the essential design toolkit, engineering for success. Okay, so let's unpack this toolkit. First up, we have compliant features, which are just a really elegant solution. These are design elements engineered specifically to flex and absorb tolerance variations. So instead of hoping two rigid parts just magically line up perfectly to the micrometer, you engineer one of those parts to yield just a tiny bit. It beautifully absorbs any of those minor printing inaccuracies we talked about earlier, making the parts click together securely and flawlessly every single time. Next, we have chamfers. You've probably seen these. They're slanted or angled edges applied to the geometry of a part. Instead of two flat, hard edges abutting and catching on a microscopic layer line or, say, a tiny overextrusion, a chamfer acts like a physical funnel. It seamlessly guides your interlocking components together, completely bypassing those annoying little machine quirks during assembly. Now, when you need a genuinely tight friction fit, grip fins are your best friend. These are small, really targeted extrusions along the edge of your model. When you insert the part, these tiny fins are actually designed to slightly crush. It's an absolutely brilliant way to force a perfect fit because you're letting the plastic itself dynamically adapt to the physical gap. And rounding out our toolkit, pun absolutely intended there, we have rounded corners, or fillets. These curved junctions are, well, they're basically essential. They significantly reduce stress concentrations inside the part and help prevent unwanted warping. By actively combating the natural shrinking behavior of cooling plastics, rounded corners really help you maintain dimensional accuracy across your entire print. All right, let's look at the big picture in section 4, the digital warehouse future, scaling the process. Thousands. That number represents the thousands of FDM 3D printers working 24/7 in Slant 3D's high-volume print farms. We are moving right out of your desktop design space and straight into the industrial scale application of these exact same principles. The design features we just went over, the chamfers, grip fins, compliant features, they aren't just neat desktop theories, they are industrial facts. Their work keep thousands of machines running smoothly and predictably day in and day out. And because this whole process is agnostic to those individual machine quirks, it unlocks literally limitless scalability. It doesn't matter if a client needs a run of 100 parts or 100,000 parts. Mastering these robust tolerance designs allows for incredibly reliable, massive scale production without breaking a sweat. Which naturally brings us to this wild concept, the digital warehouse. Here's how it flows. First, parts are stored digitally on a server. Second, because they are digital, designs can be updated in real time. Third, parts are printed strictly on demand. And fourth, this totally eliminates the need for extensive physical inventory. It completely changes the speed, the cost, and frankly, the flexibility of modern supply chains. It's a total game changer. And we really can't ignore the environmental efficiency here either. If we compare traditional manufacturing against this kind of sustainable print farm system, the differences are pretty stark. Traditional methods usually mean high emissions from carbon-intensive global shipping and massive physical warehousing. The Slant 3D system drastically reduces that footprint by utilizing digital storage on servers and cutting out those long carbon-heavy global shipping steps entirely. So, what does this all mean for us? What you should really take away from this explainer is that it all starts with design. By taking control of your tolerances in the CAD phase, actively using those compliant features, the chamfers, the grip fins, you're doing way more than just making a peg fit a hole. You are truly empowering your design to connect directly from your desktop ideas to large-scale sustainable factory production, completely seamlessly. I want to leave you with a bit of a provocative thought today. Are we looking at the end of the physical warehouse? Seriously, if parts can reliably be pulled from a server and printed perfectly on demand, literally anywhere in the world, the way we store and ship physical goods might never be the same again. Thank you so much for joining me for this explainer. Keep designing smart, and I'll catch you in the next one.